introduction to microcontrollers, and we are going to first define what microcontroller is. And if somebody asks you what a microcontroller is, then you can just say that a microcontroller is a computer that is implemented on a very large scale integration. Into bracket, we usually call it VLSI chip. VLSI chip, that is very large scale integration chip. And basically a microcontroller usually contains all the things that a microprocessor has, plus one or more. So if you are to define what a microcontroller is, then there are three things that you must look at, especially if you are looking at the definition of a microcontroller. There are three things that you should look at. One of them is that you should say that it is a single chip. It is a single chip, and it consists of CPU and also the memory. It consists of the CPU and the memory, and also it has got what we call the I/O ports, that is the input-output ports, timers and other peripherals. Timers and other peripherals. So that is what the microcontroller usually contains. And also another thing is that it has got, it is small in size and also has a low cost compared to the microprocessor. So let's look at the differences between the microcontroller and the microprocessors very, very fast. The differences between the microcontroller and the microprocessor very, very fast. So let's have a small table here that is going to give the difference between microcontroller and microprocessor. The differences between the microcontroller and the microprocessor. So when you talk about the differences between the microcontroller and the microprocessor, there are several differences, and the differences usually come in terms of you can talk of there is architectural, what they process, and also what they do. So you can also talk of the first difference that you can talk about. Number one, we can have the microcontroller this side, microcontroller, and then we can have microprocessor. So the first difference between the microcontroller and the microprocessor is that this one is just a single chip. This is a single chip, and this is a single chip, and much of the remaining circuitry is usually a complete computer. That is, it usually has a RAM, it has a ROM, serial interface, parallel interface, timer, and interrupt handling circuit. When you come to the other side, this one is also, it is a CPU. It is a single chip that is a CPU. So you can simply say that it is a CPU, and basically it is always used in the computer. So that is one of the differences that exist between the microprocessor and the microcontroller. Another difference that we have is that this one usually consists of memory. This one usually consists of memory, while this one, both, you can say memory, I/O ports, memory, I/O ports should be connected externally, are connected externally. They are connected externally. That is, you have your CPU, then outside there you have the memory and also the I/O ports that are connected externally. The other one is that the microcontroller is always found in small minimum component. It's always found in small minimum component designs performing control-oriented activities. So this one, you can say found in small minimum component minimum component, designs, performing, control-oriented activities, Then, if you come to this side, that is in the microcontroller, it is always used as CPU of a computer. So this one is used as a CPU of a computer. It's always used as a CPU of a computer. Another main difference is in terms of the instruction set. It is in terms of the instruction set, whereby the microcontroller instruction set usually caters for control of inputs and outputs. It caters for control of inputs and outputs for the microcontroller. So, when you talk of the difference as far as the instruction set is concerned, then this one, the instruction set caters for control of inputs and outputs. Control of inputs and outputs. Control of inputs and outputs. Then, when you come to the instruction set of the microprocessor, then it is always processing intensive. So this one is processing intensive. So those are the major differences that you can talk about as far as this microcontroller and microprocessor are concerned. Now we can look at the components of a microcontroller. So microcontroller basically has several components. So we are going to look at the major components that are found in microcontroller. And one of the components that we're going to look at is, so we can talk of the components of microcontroller, of microcontrollers. So we are going to look at the components of microcontrollers. The first one that we can look at is the memory. Memory, basically, as we all know, memory is always used to store programs. So memory is used in order to store programs. The other component that we can talk about is the timer. The timer has got several uses in the microcontroller. One of them is that it is always used to measure frequency. Also, it is used to measure period pulse, width, as well as the duty cycle. Another work that it can also be used for is to create time delay, as well as to generate waveforms. So basically, that is what the timer is supposed to be used. So remember, timer is used to measure frequency, period pulse, width, and also the duty cycle, as well as creating time delay and generating waveforms. Another important component that is always found in this is ADC, that is the analog to digital converter. Analog to digital converter. Analog to digital converter. So as you know that microprocessors, the microcontrollers usually use sensors, and it is very, very important that this particular voltage is converted. So the basic work of the analog to digital converter is to convert a voltage from the sensor into a digital value, because it is a digital equipment. So it is going to convert the voltage from the sensor into a digital value. Another component that we can talk about is the number 4, is the DSC, that is the digital to analog converter. Digital to analog converter, and this one we can also call it DAC, or we can call it PWM, which means the pulse width modulation. So in the work of this is always to convert the digital value into a voltage output. Converts a digital value into a voltage output, and also the PWM output can be used as a rough digital to analog, a motor driver, or for many other processes, any other processes. Another component that we can talk about is DMA, that is direct memory access. Direct direct memory access, what we usually refer to as the DMA. The DMA is always, the main work of the DMA is always to speed up the aspect of data transfer. When the communication is taking place, the data is always controlled, especially when you're talking about the DMA. It is always controlled by an external device. And when we talk of the DMA, in the conventional way of data transfer is that the data usually has to be transferred to, there is a register that usually called the accumulator. The accumulator is usually used for data transfer. So when you talk about the DMA, then this DMA will ensure that the data is transferred directly. Yeah, the data is transferred directly from the I/O device to the memory without passing through the accumulator. So that is the main work of the DMA. It is supposed to ensure that it is a technique that ensures that the data is transferred directly from the I/O device, that is the input-output device, to the memory, that is a RAM, without passing through the accumulator. Another component that we can also mention here is what we refer to as the parallel I/O interface. That is parallel I/O interface. The parallel I/O interface, which at times we usually refer to as the parallel port. The parallel port. And the parallel port is always used in order to transfer data lines. So when you want to transfer data in a situation where you need several bits, so it means that you have more than one bit at a time. Data is transferred more than one bit at a time. Like maybe you can have that has got several lines of data transfer, and this one usually happens simultaneously. Then we have what we call the serial interface. The serial interface. And this, just like the opposite of that, there is the opposite of the parallel interface. The data transfer is done using one line, and that is one bit at a time. And therefore, this method of transfer usually require only one data line. And in that case, it is always said to be resource efficient. And there are two ways of by which this serial interface can be achieved. There is what we call the asynchronous serial interface. And this one usually enables the data bits to be transferred serially without using the clock signal to synchronize the sender and the receiver. So you don't need a clock signal to synchronize the sender and the receiver when you are using a serial asynchronous serial I/O interface. Then the other one is called synchronous. So this one, the data is transferred serially, and it uses a clock signal to synchronize the sender and the receiver. Another component that we may also talk about is what we refer to as the memory component circuitry. Memory component circuitry. The memory component circuitry. So when you talk of the memory component circuitry, the main work is always to generating appropriate control signals to be used by the memory chips. So it is supposed to interface. This particular component is supposed to generate appropriate control signals that are supposed to be used by the memory chips. Then we also have the DSP, that is the digital signal processing. Digital signal processing, that is what we refer to as the DSP. And this one, the main work is always to support DSP computation, that is the digital signal processing computation. So that is what it is supposed to do. There is another component that we can also talk about. We can talk of the other components Like we talk of the memory management unit. Can talk of the memory management unit. Memory management unit. The memory management unit. So the main work of the memory management unit, it is always a computer hardware that is responsible for handling accesses to the memory as requested by the CPU. And it has got several tasks. The several tasks that it has usually involve the use of the virtual and physical address translation. That is the first task that it usually does. It also does the memory protection. The memory protection. The third one, it does what we call the cache control, cache control, and acts as a buffer between the CPU and the memory. The fourth task that it does is the bus arbitration, and also simple computer architecture bank switching. So those are the 5 tasks that the memory management unit usually do. The other one that we can also talk about is the Watchdog Timer. Another component is the Watchdog Timer. Watchdog Timer, that is what we call WDT. The main work of the Watchdog Timer is that it is supposed to relieve the controller or help the controller from what we usually call both the software and hardware upsets. Both the software and hardware upsets. Hardware and software upsets. Basically, there is always time that it takes for a given process to be completed. If it takes more time than that, then it means that the Watchdog Timer will tell the system that there is a problem. So this one, the problems can be as a result of electrical noise or electrostatic discharge, or maybe due to any hardware-related problems. And if this happens, then there will be overflow, and the hardware reset is initiated in order to restart the microcontroller. The process itself usually avoids the system from having a malfunction for longer than 16 milliseconds, and this one is usually under 12 megahertz frequency operation. And when this WDT overflows, it usually pulls the reset pin for at least 2 state times, resetting the microcontroller and other devices connected to the reset line. So basically, the main work of the Watchdog Timer is always to ensure that the problems of software and hardware upsets are, the system is relieved from the problem of software and hardware upsets. So that is the main work of this, or any malfunction. We usually refer to that as malfunction, and especially if the malfunction takes longer than the time that is required, because each and every process usually has allocated time within which it can be processed. And then if it takes longer, then that one will call for the WDT, and the WDT will reset and also stop in order to avoid a malfunction in operation. Then we also have another component that we can talk about, that is this high-speed input unit. High-speed input unit. High-speed input unit. And this high-speed input unit, it provides automatic recording of events. High-speed output unit provides automatic triggering of events and real-time interrupts. So that is basically what it does. One of them is that it provides the automatic recording of events, and also it provides automatic triggering of events and also real-time interrupts. And here we can also have a basic diagram of the generalized function diagram of a block of a microcontroller. So it usually consists of the CPU, we have the timing and control circuit, we also have the oscillator circuit, then we have the ADC channels and also the RAM, the ROM, the registers. Of course, the registers, we'll talk about them later on. We also have the parallel and serial interfaces. Then we also have DSC, or the pulse width modulation output, and also the timers, counters, and the interrupt logic. So that is the functional block diagram of the microcontroller.